The next section that we're going to cover is 18.2, and it is on spontaneous processes. So first, a definition. A spontaneous process is a process that occurs without the addition of extra energy from the surroundings. I'm putting extra in quotation marks because if you recall from chapter 6, a long time ago, all reactions require addition of some energy, the activation energy, whether the reaction is exothermic or endothermic. In order for any chemical reaction to proceed, the system has to receive enough energy to make it up to that high point called the transition state of the energy diagram. This energy, the activation energy, sometimes comes into the system synthetically, like you put it on a hot plate or you light it on fire or something along those lines, or sometimes the system is able to just suck that energy from the surroundings. If the activation energy is very low, for example, it may be able to just simply pull that energy as thermal energy just from the normal environment, and it doesn't need any sort of additional energy input in. So just for the sake of reminder, let's write down that all reactions, all of them, need some energy input. The activation energy, E sub A. Spontaneous processes that occur without the addition of extra energy. Spontaneous processes are able to get their activation energy naturally from the surroundings. So they don't need a chemist or somebody to come along and dump extra additional energy in. So spontaneous processes are things that are just going to happen whether or not we initiate them. They're just going to go on their own. So for example, or several examples of spontaneous processes: organic decay, which is a fancy way of saying rotting, decay, whether you have rotting fruit or vegetables, or a tree that has died and fallen down and rotting, or rotting and decomposing bodies of some sort or whatever. That is a chemical process, the organic decay, and it does just happen spontaneously. You don't have to do anything to the dead tree to get it to slowly start decaying. Rusting is a spontaneous process. If you have a piece of regular metal sitting out in your driveway, especially lately, it's been raining constantly, it's just going to spontaneously rust, and you don't have to do anything in order for the rust to start forming. Sometimes spontaneous processes, we can think outside of the chemistry box, outside of the realm of reaction. So a ball rolling down a hill. If you have a ball, you're holding it up at the top of the hill, and there isn't any barrier that's keeping it up at the top of the hill. Like, for example, if you remove your hand and your hand isn't holding it in place anymore, the ball is just going to roll down the hill on its own spontaneously. You don't have to do anything to get it to roll down the hill. You don't have to kick it or push it. It's just going to fall. A volcanic eruption is spontaneous. We don't have to do anything in order to get that reaction to take place. It's just going to go. Gas expanding to fill a container. If you have a helium balloon and you pop it, that helium is going to expand to fill the new container, the room, or whatever, the atmosphere, wherever you are. You don't have to do anything to get the gas to expand. It's just going to go all on its own. Dissolving a soluble solute. If you dump a bunch of salt into a glass of water, that salt is just going to dissolve. And you don't have to heat it up. You don't have to do anything to it to get it to dissolve. And a lot of times, or not a lot of times, occasionally you'll see processes that are spontaneous, but only spontaneous at a specific temperature. So sometimes spontaneous processes have temperatures associated with them. For example, water freezing. Water freezing in and of itself is not spontaneous, but at 0 degrees Celsius, water freezes spontaneously. So at that particular temperature, if you have water, it's just going to freeze, and there isn't anything you need to do to help that process get going. Spontaneous processes are usually exothermic, but not always. It's a pretty good rule of thumb. If you see an exothermic process, generally it's going to be spontaneous. You do want to take a little bit of time to ask yourself, is this actually spontaneous, yes or no? And a lot of times you can just reason your way through figuring out whether or not it's spontaneous, just based on observations that you have made, your own experience.
Okay, ready, John? Okay, let me get on a good spot here.
So most of the time, if a reaction is exothermic, it's spontaneous. If it's spontaneous, it's exothermic. So we can write this in both ways. Spontaneous processes are usually exothermic, and vice versa. Exothermic processes are usually spontaneous.
Responsible for this much of the team. You need a car you can count on.
There are very few examples of spontaneous endothermic reactions, and I'm going to show you one. Example of spontaneous endothermic. The reaction in which water, solid, melts to a liquid has a delta H of 6.01 kilojoules per mole, which means that it's endothermic. Energy is required. Because the delta H is positive, that means that the reaction requires energy to be put in. So it is overall an energy in endothermic reaction. But as you know, at the right temperature, this is spontaneous. If you have ice sitting out on the table, it's going to melt. This is probably because the delta H is very, very small. It doesn't take a lot of energy to get this reaction to occur. But this is one example of a spontaneous process. You are going to learn that in later sections in this chapter that there are multiple factors that dictate whether or not a process is spontaneous. It's not just exothermic or endothermic. That's a part of it, but it's not all of it. So that's the end of section 18.2. I would like you to write some study questions for this. I want you to know the definition of spontaneous. I want you to be able to provide some examples of spontaneous processes. And that's pretty much it.